I'm going to start the last project session for the project number 1. And before we actually start and that we can actually answer to your questions, we are just going to have a small follow-up on the project, just to answer a few questions that we got a lot by email in the last week. And we will also give you some information about the project presentation that will take place next week from 10 of the morning. So one of the questions that you got quite a lot is about which area to actually use in the calculations of the heating load. So if you had a look at the CSV file, you can see that you have two different types of area. You have a heated ground surface and you have a thermal envelope surface. In theory, for the conduction losses, you should use the heated ground surface, and for the radiation, you should use the thermal envelope surface. But in order to make it simpler for the project, just use this area, just use this data all the time. So this is the second column in the Excel file. I think most of you already use this one all the time. If you take a look at the other column, you can see that it's more or less the same numbers most of the time, with the exception of some buildings where you have a 0 square meter area. So always use this one for the area for the calculations. You had a question?
No, so we neglect the second.
Yeah, so basically you don't consider this column at all, okay? For simplification, just focus on this one. If you have already done your Newton-Raphson and these kind of things with the two areas, it's also fine. I mean, it's not wrong. Just tell us when you make the presentation of your project next week, so that we are not surprised if you get different values of the case. And the second question that we also get quite often is about how to compute the typical periods. So this is basically the last part of the first project. So as you know, why do we need clustering? Why do we actually need typical periods? Well, we have quite a lot of data, we have quite a lot of points. So the idea of the clustering is to actually simplify this data set so that you can use it later in the following steps of a project, like for example, the MILP project. So what you can do for the clustering is that you cluster in relation to two different parameters, to two different inputs. So you cluster based on the external temperature, and you also cluster based on the irradiation. So you have a clustering based on two parameters. The procedure is the following. First of all, you select the data set that you need to analyze. So you consider the external temperature and the irradiation. Then you have different methods to actually analyze this data. So either, for example, you take 1 month, and then you make the average of the temperatures and of the irradiation, and then you have some kind of average values. But we also ask you to apply a clustering method. So that means basically to apply the k-means method that is actually implemented in MATLAB. So it's already a function that is defined, but you don't need to develop by yourself. All the information on the function is actually given on this link. So basically, it's just sending all the data that you want to cluster on the k-means function, and you will get all the results that you need. So once you have done the clustering, you need to estimate the quality of each period. So for example, if you have 2 typical periods, 5, 10, obviously you will get a higher accuracy if you have more periods, if you have 10 instead of 2. So we ask you to calculate as well what is the error that you get using a clustering approach with, for example, only 2 typical periods, or 3, or 4, or 5. So for example, if you use a clustering method, you get a difference between the reality and the cluster of 5%, 10%, 25%, and we want you to think a little bit about it. So what you can do basically is applying these kind of functions to try to apply this function not only for 2 typical days, but also for 3, for 4, for 5, and to evaluate the difference in terms of the quality of the typical periods. And what you should have for next week, when you will actually give you the presentation of your project, is that you need to have the data considering 4 typical days. So what you should have is something like this. So you cluster in relation to the temperature and the irradiation. You have 4 different periods. You will get the temperature and irradiation for each typical day. And for every building, you can apply the equation of the heating load in order to calculate the heating demand. For the presentations next week, in the project description it was written like more or less 3 minutes presentation. We discussed with François and among each other. And it's going to be a 5 minutes presentation, so you have a little bit more time to present the methods, the results that you get. So if you have any issues for the rest of the project, this is also like a good way for you to present like the problems that you have and that you can see exactly how to fix that. And instead of having only 1 or 2 slides of presentation, you can have like 3 or 4 slides, and it will be completely fine. All the slides that we have now will be uploaded on the Moodle, so if you have some doubts about some information, you can always write us. You can also check on the Moodle. And the aim of the presentation is more or less to check like what you have done, like in terms of the calculations of the building coefficients, of the heating demand, on the clustering. And you can more or less follow this kind of structure for your presentation. So first of all, like explain the context of the project, explain how you calculated the different building coefficients with the different results that you get, show more or less like how the hourly demand looks like over a complete year, and then what are the different typical periods that you have. And finally, what we ask you to do is to estimate the accuracy of your typical periods, as we discussed before, and to also mention that in your presentation. So the presentation next week is a good way for us to check the progress of your project and for you to get some feedback about what you have done so far. Yes?
Is a typical period of the temperature necessarily the same as for the simultaneous?
So you have like one, for example, you have like 1 period, and you will need, when you will do the clustering, you will get 1 value for the temperature and 1 for the irradiation. So basically, it's like 4 sets of the data of a matrix of 2. And then the heating demand, you can calculate it from the equations.
So it's not one single value, but it's a time series in each of these boxes.
Oh yeah, you mean in relation to the frequency?
Yeah, this is also missing, but like not missing in your slides, but I think typical period number 1, the external temperature, this is not only 1 temperature, is it?
No, we expect only 1
So-
temperature.
Okay.
Yeah, it's something that we make it to the same.
Okay, sorry.
For each
So
period,
we-
we also have an operating time in hours.
Okay. Oh, fine.
So just to follow up on your question, you have 1 value for the temperature, 1 value for the irradiation, and what you also say is like the frequency of your period. For example, maybe this one represents 25 hours, maybe this one represents 200 hours, and these kind of things. Okay? Yes?
Wouldn't there be cases where irradiation fluctuates, where external temperature is steady?
Yes.
So,
And that's the reason why you need to do clustering, because basically it will consider like all this kind of information, and it will find like a representative point in relation to these parameters. That's a good question. Any other information that you need or that you're missing for now? Right. So we are here to help you in relation to the Newton-Raphson and the rest of the project. So if you have any question already, you can start coming to us. Thank you.